Welcome to all to class number 2. Already I uploaded class number 1. See, those who are coming to class number 2, it is a condition. First class number 1 should be thoroughly studied. In my course, you should follow the way I am going to tell. Not the way simply like you go for a video in YouTube for entertainment purpose. If you are serious and want to learn and get good marks in examination. See, in the title I wrote exam oriented course, but here see, I don't write it. Because when I come to a class, there is no exam oriented class or crash course, nothing like that. Whatever I tell systematically. Only thing is, this course is somewhat like a crash course because limited time. So I'll briefly tell the concepts. And I told you, some of the principles all, I will not, theory part, I will not be able to tell. That you have to study. And remember, each and everything I tell, you should follow and listen. Go through entire class. If I tell some example, so many times confusion comes. So about requirements all, shall I take higher value, lesser value, etc. Then I will give some practical example. See, simple I will tell you. Simple. Examination for pass, minimum requirement is 40 marks. What it means if I ask my students, they will tell, sir, we should get either 40 or more than 40. No, minimum. Sir, minimum means that way, sir. You should get more. They understand. But when the minimum comes there later in structural engineering or strength of materials, stress strain, they go other way. Or if I tell speed limit in the road, say for example, 60 kilometers per hour, 60 kmph is written. That is called what? It is called maximum permissible speed or speed limit. I will ask the students, what it means? You should drive at a speed of maximum, no, either 60 or more than 60. They will tell, no sir. They will tell, no sir. Sir, maximum 60 means, sir, lesser, sir. See, someone will tell, maximum spending per month, parents limit to, say, 5,000 per month. Means what? You should spend either 5,000 or less than 5,000. Correct. If I tell more, no, sir, maximum 5,000, sir. There they understand. Or anywhere, auto minimum, 25 rupees means. Pay either 25 or more than 25. You cannot pay less than 25. So, when such things comes, I give example. Go through example. Remember, all what I am telling, you should listen correctly because you should accept the fact. You are attending a class from a person who knows much better than you. That feeling should come to the mind first. Not that feeling, we already know. See, by this time, so many colleges, strength of materials already started, I think. This chapter would have been over. Maybe they are in SFD, BMD or maybe bending stress, something like that. They will tell, this all we know. What all we know? When they come to my class, I will show them they don't know anything. But they may be knowing some formula, but systematic way, they are not knowing. So, I will not repeat each and every time. Only once in a while I will tell. Those who are serious, do it. And everything I tell right here. Prepare a notes simultaneously. If time is there, if at least 2 months are there for examination, I would have prepared notes in PDF format I would have given. I got plenty of questions, problems solved with me. Solved earlier for students. But now, that much liberty is not there. Let me see. If exams are scheduled, it is scheduled after 15th March, I think, for you. Suppose it goes further, a little later, I will decide. First of all, I should decide. I told last time whether to continue or not, but class number 2 I am uploading. Further continuation, I will observe more. Response, I will see further more. If I feel not satisfying, or if I feel student community, the present generation student community does not deserve it, I will do my other usual works. I won't waste time. See, my busy schedule, suddenly in between, I have to arrange and prepare this class. But when I teach, I forget everything that way. My only intention is to teach 100% it should reach you. Okay, now, last time I gave some formula solve for you, solved a problem for understanding. If the offline class I will tell, have you solved? Yes. Understood? Yes, sir. Correctly understood. Here I can't ask. Comment section, you should comment. See, I am not getting any comment. See, comment section, usually I have seen in YouTube class all, finding mistakes, comments all there. You won't get that chance. But you should, in the comment box, comment section, you tell your opinion. What way you want. Don't tell me how to take the class. No. Nobody can tell me how to conduct the class. I will conduct the class the way I want only. It is my unique way. As I told, simple language, no artificial accent or what, shouting. Shouting I will do sometime only to highlight some point. Okay, I will go further now. See, now, first remember, simple stresses and strains. I have not told anything last time. Simply I solved a problem, just to give confidence. See, crash course means that way. What I am telling now need not be told, but I am telling. See, you consider a member, you should write all this one. See, one side fixed, some support is there. This fixed all I will tell later. See, a member this way. See, I will fix one side. Other side, I will apply a force, axially P. Length of member I will tell later, not now, P. See, this concept is very powerful when you go to compound members. When they give question of this type, or see, this type of question, then this concept required, or this is actually the basic concept you should know. The actual basic meaning of this equilibrium part. See, now, apply a force P. Length all I am not interested. Suppose I take the point A here and B here. See, somebody can ask, sir, fix at A. Okay, no problem. It hardly matters. One, you don't by heart left side fixed. One side supported, other side free. See, like this. Now, I am applying a force P here. See, the cap came out. Okay, I should have another way. I'll take some other member for that matter. To understand something else. Okay, I got some member here. See, okay, this is gone, broken. Okay, some small, that is not sufficient. Okay, no problem. Searching for something. Calculator will not do because if I apply too much force, calculator will break. Okay, leave it now. Okay, I am not able to get it now. See, this way. Apply a force P. This P will try to move this member. See, I will take a member here, I will apply a force this way. See, it is moving. It is not equilibrium. Then there is no internal effect on the member. It is simply moving. Nothing will happen. No pain, means no strain, nothing. Finally, see, I move further here. See, you can see the board here. Okay, stop. Now if I further move, this cannot move. Why? There is a support there. So if I move that way, from there a reaction will come. From this way. So the member will be in equilibrium. This way. See. Now therefore, see, always remember, equilibrium is direction based. Axial force, shear force, bending moment, torsion, they are nature based. I think I told last time. I think yes, I told. They are nature based. One table like I made last time. See, this is equilibrium is always direction based. There is, see, one hand you can explain. See, I am applying a force P this way. Because of force P, it will try to move the member to this side. Or see, like this. Now, therefore, for equilibrium, the support at A will give a reaction. See, if I apply this way, if you hold here, you have to apply a force like this. So I will show it here. This is a given member. That is, see, further, you are right here. Here, this is, first step is you have to ensure equilibrium. You are right. In the complete strength of materials, any chapter, first step to ensure equilibrium. So therefore, now I will do arrow mark. What happens? You apply a force P here. For due to that one, left side, if I take A and B, there is a reaction R at A equal to P. Okay, now the member is in equilibrium. Same way, see, I'll write here. Suppose the member is, see, I have no negative, no positive. Applied force is right side, reaction is left side. Sometimes people tell reaction is negative. What negative? When I show the direction, then negative should not be there. That's all common sense in mathematics. See, like you tell profit is positive. If you are adding profit and loss together with sign convention, then if you take profit as positive, you should take loss as negative. Suppose the person is calculating only losses. There is no negative. He will keep on adding the losses. See, now, or AB here, imagine, see, or, you write here, or. Apply a force this way. This I will not repeat once again in my class now. Then, see, what happens is, then at A, this is B, due to this applied force P, at A, see, force is this way. For equilibrium, there will be reaction at A to right side of P. See, this is direction based. How you call? Applied force, right side, reaction, left side, equal to P, same. Applied force here, left side, reaction, right side. When you tell forces, you should tell left, right, direction. But not when you tell compression, tension, their nature. Okay, I'll explain. Okay, now, see, this is, so many times exam, they can give question like this. If they give question like this, suppose I will tell you why. Suppose I want axial force for the section. See, suppose I want axial force here for the section, or axial for a section here. Axial force is nature based. It will be compression or tension. So you can tell, if I take a section here, axial force. See, now I am coming to nature based. When you tell axial force, no right side, no left side. Later, remember, you see my SFD BMD course, I have been shouting for past 100 classes. When you go for bending moment calculation, so many places they tell clockwise, anti-clockwise. It is complete meaningless. They will tell left side clockwise positive, anti-clockwise negative, right side clockwise negative, anti-clockwise positive. No, that is not the way to define the section force. At that time for bending moment, I told you last time, you should tell sagging or hogging. That chapter I am not taking because marathon classes are running there in the course SFD BMD. Little later, when our course reaches a level, I will tell you which are the class number required for you. Study only that much. Sufficient. So, axial force here. So, here, axial force for cross section considered. Cross section considered. Here also, axial force for cross section considered. This sketch I am removing now. Considered equal to. See, what you have to do is make a note now only. When you are considering equilibrium, you have to consider entire system. See, entire system. Right side P, we need left side P. Left side P, see, I am using only one hand. You need for equilibrium right side P. But when you find section force, I already told you, section force, axial force, then we got later shear force, bending moment and torsional moment. These are all section forces. Section forces. For that one, no direction. Direction considered is nonsense. Instead, nature considered. Instead, nature considered. Just a minute. I forgot to put my camera mode, mobile mode in the aeroplane mode. Because suddenly some call comes, it will be a problem. I realized earlier, during recording, some call will come. It creates problem then. Okay, 1 minute. Okay. Now safe. Now fully safe. See, such things I talk. I told no artificial. Sometimes people will not talk this way. They will tell these are not to be told. Why? Let us talk freely. What is there? Okay, now when you want axial force for the cross section, see, consider cross section. Consider nature and consider only one side. This I told last time. You should write again and again. Only one side. Which side? Whichever side you want. No restriction. If you want to consider right side or if you want to consider left side, no problem. But only one side. Okay, now see. See now what happens now. Axial force, I'll come here now. This is the, I don't think, cross section. I'll show red color. To understand the cross section, see, cross section consider. To understand. You can also do that way. Use a red color. To understand. Okay, now. When I want axial force for this cross section, I will tell now in the remaining part of the course, this I will not keep on repeating every day. There's a limit. See, suppose this is a crash course. Someone will tell, is it crash course? Yes. Then this much you are explaining. I will tell them, crash course means not crashed like that. Crash course means very slow, but unwanted skip, limited. But whatever you give 100% that way. See, consider cross section here. Look this side or this side, whichever side you want. Okay, I will look this side. Never tell right side, left side. In my class, so many times I will show anger on them. I will ask the students, tell me right or left. They will tell right, sir. Then I will look at them like this. Sorry, sir. You told no direction. You should tell tension complete. And why you told? Sir, you only trapped us. This is a recorded class, so I can't do it. But in case I go live little later, I am planning to go live if possible, so that you can participate. Live participation has a double effect than seeing recording, because you are involved. You see how many mistakes you will make. I will force you to make the mistake. I will force you to make the mistake. Why reason? Not for fun. By forcing you to make the mistake, I am not getting any enjoyment. I know where I stand, where students stand. It is, see, if you see that someone is hurt or underestimate someone or make him feel bad or sad and enjoy, it is called sadistic mind. I am not sadistic. In the class also I do it. I underestimate them. I will show them where they are. I will push them down and down. But they are happy. They know why I am doing it. So many are telling, some more and more you push us down. When you come up, sir, we will come much higher. I will ask, above me? Sir, don't tell that way. So, purpose is what? To give inspiration, or they should get what? Motivation. Oh, I made a mistake earlier. See, if the online chat is there, I will ask, axial force, tell correctly, right or left. Comment box, it will start coming, right, like that. But if I look this side, they will tell left. Suddenly somebody will comment, sorry, left, right is not allowed. Same way for bending moment. Clockwise, anti-clockwise not allowed. If any of the places in the colleges or wherever, if it is told, don't make an issue. Don't ask them, see his classes, don't tell that way. Don't make an issue. But so many people who you tell clockwise, anti-clockwise, they have changed now. They are now, because of my constant shouting, so many people, they changed. They will not tell anti-clockwise, clockwise. They will tell sagging, hogging. See? Okay, now, come here. If I take section here, section force I want. Look this side. See, I'll write here now. If I look this side, see, this is the mark I am showing. Just a face. Then, see here. Axial force is hold. You should hold your hand where the cross section is. See, here. I will ask the students, what is one? This is tension or compression? Sir, tension. Very good. Answer. So, answer is P, tensile. Tensile. if you look right side, or if you look left side, answer. I will tell them in the class usually. If you look right side, it is tensile, but be careful when you look left side, instead of tensile, it is what? They will tell compressive. Suddenly they will tell, sorry sir. See, whether you look right side or left side, axial force should come same value and same nature. You can never get right side if you look tension, left side you look compression is nonsense. It is nonsense. Whether you look right side or left side, but only one side you have to see. You have to see only one side. Only one side you write 1,000 times. And also nature based, right? No direction. Direction is for equilibrium. Slowly you will realize, as I do more problem, you get accustomed to it. Therefore, whether you look right side or left side, answer is same. See later for bending moment, I will ask them, if you look right side, if you get positive, if you look left side, instead of positive, what you will get? The way I am trapping, they will tell negative. Then they will realize, oh sorry sir. Sorry sir, see, they will tell that way. Irrespective of you look right side or left side, it is sagging, means sagging only. If you get plus from that side, this side also will give plus. Actually that chapter, SFD BMD, is very, very interesting, and that is my trump card. But that class I am not taking because of time problem. I'll see later, exam getting postponed, and if time is still there, I may consider that chapter also briefly, only some required questions. But if I tell required question, it will be sufficient for you. Okay, now see answer. Or look left side. See now, do not see left and right force. When you look left side, see. Right side if you look, tension. Left side, oh, again tension. So even if you look left side also, it is P, tensile. Therefore, see, you write here, irrespective of, sometime nobody will tell in my class, sir, irrespective, sir, only 2 hours are there. I will tell them, don't teach me English. I usually will not make spelling mistake, and some rare cases I make spelling mistake. Why? Not my mother tongue. But grammar mistake I will not make. Very, very, very little. So I will tell them, don't teach me English. This is to stress the point. See, irrespective of means sometime when they ask something, little food, you tell Salpa in Kannada. Sorry, Kannada I should not use here because class is for everybody, but still Salpa Kannada. Here Salpa, tell little. Why you are telling that way? They have to insist. So therefore, irrespective of right here, you should write whether you look right side or whether you look left side, whichever you do. But remember, only one side you have to consider. Condition. I will stop this one now. Axial force for the cross section considered. See, the section forces are for the cross section. They are not for the member. Again problem. Member is in compression, member in tension is okay. But that tension, compression or shearing force or bending moment or torsion, they are all for the cross section. They are to be resisted by cross section. How it is resisted, I will come now little later. So today's class, I will give much more explanation. See, in the beginning, make all these things clear. Then we will start non-stop numericals. So axial force for cross section is P, nature, tensile. I will ask the students, sign. No sign. One side tell tensile, no sign. Over. Now, same way here. See, if I cut here, you look right side. Suppose you look right side. Axial force is, I think I should not explain. See now. Too much, my hand will pain. Axial force is P, nature, compressive. Or if you look left side, see here, This way. Once again, P only compression. Therefore, right here, irrespective of whether you look left side or you look right side, axial force for cross section considered. Okay, I forgot right last time. Cross section considered. Here I forgot here. Cross section considered. Okay. Considered is how much? Is P. Oh, I am asked. This is my usual way I ask in the class question. If I start live class, you have to answer. Till you give the answer, I will not continue. Is P nature compression. Sign. My students will tell in the offline class, sir, no sign, sir. Why? By that time, so many times they made mistake, and I will show little angriness. And for one thing I will tell you, if I become angry in the class, they know it is for fun. Sometimes I will look at them like anything. They know it is for fun. In my entire teaching of around 39 years, so far, not a single time I got angry with the students. I have infinite patience. If they make mistake, they are meant for making mistake. I am there to correct it. They came to me for learning, so I am there to teach perfectly. So I never get angry when people tell wrong answer, or when they tell we don't know, or complete nonsense if they tell. I never get angry. If at all I show angriness, they know it is for fun. They also enjoy it. But I get angry for indiscipline, terribly angry. You should know in my classes, in colleges all, how terribly angry I get. That is real angriness only. If for indiscipline, usually that problem is not there. They keep quiet. They never indulge in anything. They know that the moment I get angry, they are thrown outside. No second chance for them. No requesting. I will tell out. Okay, over. Now, this is axial force. Remember, so I will conclude here now, not conclude the class. When you want, right here, in a box right here, this way box. When you want to find axial force for any cross section of a member, first step is to ensure equilibrium. That is the most important. First step is to ensure equilibrium. Once you ensure equilibrium, equilibrium means you consider action and reaction. See here, this is action, this is reaction. This is action, this is reaction. Action and reaction together, it will be equilibrium. And equilibrium, when you consider action and reaction, it is always, equilibrium is always direction based. It is always direction based, not nature based. No compression tension. Right side, left side, upward, downward. See, one hand. Go through last class once again. Clockwise, anti-clockwise. But once you ensure equilibrium, you consider the cross section for which you need section force. At present chapter, I want only axial force. Shear force BM will not come here most probably, because it is that chapter I am not doing. You go there and see how much I explained there. Axial force. When you want axial force, which is a section force, it is always nature based. No direction, nothing. And one hand is not sufficient. Two hands are required. See, compression, tension. So here, see, if I see here, or one hand you can use here, see, or see, tension. Whether you look right side or left side, it is tension P. Whether you look right side or left side, see here, compression P. If you write compression and tension, don't use sign then. You can take tension positive, then compression, you write minus, which I never do. But when you write nature, don't tell plus minus then. Slowly you can make out. Now, see, you write chance of making mistake. Question given here. Imagine this equilibrium is not maintained. Then, if I take a section here, or if I take a section here, I will ask the students, see, tell me, section force here, look that side, how much? P. Nature, sir, tension. But if you look this side, nothing is there. Yes, sir, nothing is there. So, if you look right side, section force is P. If you look left side, nothing is there, so 0. Then they will realize the mistake. Sir, no sir, confused. What confused? I told, see, support is there. If you look that side, you get one answer. If you get this side, you get some other answer. I will tell in the class, that is the last day for my teaching. I will never take one more class. It never happened so far, will not happen in this course, will not happen in future also. Then remember, therefore, see here, support means reaction is there. Or if you are looking that side, you need not find reaction. But you should remember, if I look this side, the reaction is to be calculated. So better find the reaction. Okay. Now, last statement for now. Sometimes, right here, instead of giving this way, see, or instead of giving this way, suppose in a question, if the question given is like this, P, then which is applied force, which is reaction, doubt comes. Why should you bother? Which is action, which is reaction, why should you bother? One of them is action, other is reaction. See, instead of telling one support is there, I am applying a force, they are telling I am applying force like this. Okay. Now, same thing. Now see, equilibrium is already ensured by them. See here, right side P, left side P. Okay, balanced. Or this sketch, instead of this way, they can give like this, directly in the question. Okay, PP. Okay, now you can tell no support required because equilibrium is already maintained by them. If they already maintain equilibrium, keep quiet, proceed further. See, like when you go to a meals, sometimes you have to go and get the plate from a counter and then go to the table where people will serve you. That taking the plate from counter is like finding reaction. Sometimes plate will be there on the table only. Then what you do? You take the plate from there, table, put in a counter and again take back. No. Your bringing plate is not there. Directly there, they told, go and sit there. Plate is already there, ready there for you. Or sometimes they will tell, plate is there. You bring the plate, then come to food. So anyway, if they already prepare it, equilibrium ensured, thank you, that's all. So remember, if already equilibrium is ensured by them, silently find section force. But if they give a support, then you have to first find support reaction. For equilibrium, I already told you, equilibrium section forces, so many things I told, direction based and what? Right side, left side, etc. One hand you can explain, section forces you require two hands to explain, and nature based, only one side you have to see. Equilibrium, completely you have to see. See, when you consider equilibrium, you have to consider full member. When you take section force, consider section force, you have to consider only one side. So those things already told for you. You make all these notes, and now I will continue for the stress part. Okay. See, nearly it is, I don't know how much, around 35-40 minutes I talked. For a crash course, this much not required. By this time, I would have finished the chapter only if I want. No. Learn, when you are learning something, learn everything. Then, if a twisted question given, you can solve. See, when limited part is considered in the course, whatever you learn, learn correctly. Anyway, once the course is completed, see the question paper. See how confidence you will feel then. You should, later, you will realize so many confusions for you will be gone. Even if you are already studying subject in the college or anywhere, then my course will make it furthermore easy for you. Every confusion will be eliminated. I can tell with pride, in my class nobody will ask any doubt. Nobody will ask any doubt. So far nobody asked. Here you can't ask. Or if I come live, then there also, see the comment box later. Nobody will tell, sir, not clear. Only chance is what? They are absent. If they are absent, I will tell, that is not my problem. You should be sincere. If you are absent, If you are studied by somebody else, here not that way. Here see, if you are absent to online in an online class, immediately you can go to recording. That is the advantage of online class. And all these days, from past 1 year, I am trying to make online more effective than online classes. Than offline classes. See, little confusion. Subject confusion will not be there. See, this way confusion, I will never tell here. Say, compression, sorry, tension, I will not tell. Other thing happens sometimes. Okay, I will continue now. We will continue. Now see, now actually you are going for actual part of stresses and strains. Now, one small information for you. If it is a regular class, like full-fledged class, I consider lot of concept, behavior part, and explain at least 1.5 hours for that one. Because knowledge also is important. Not that you don't require knowledge. If it's a professional class, I can at least take more than 3-4 hours for discussing some behavior here. But here that much not possible. As I told, this is an exam-oriented course, somewhat like a crash course, but whatever I consider or conduct will be full-fledged, minimum theory, and I will make the concept clear. So some comment may come, not told this, so this is not told. I told not required. Here important is I kept examination in the mind. That consider a member AB subjected to axial force P. See, this way, member AB, axial force P means not one side, both side force should be there. See, either it can be tension or it can be compression. 1 minute. Before going there, let L be the length of member. This L is called either original length or initial length. We will call in future original length. Original means no, there is no duplicate like that. Original means initial. Now, let me see, I am using red color for this one. AB cross-sectional area. This is a most important term in strength of materials. Cross-section means, I will tell you how is the cross-section. Correctly understand. I keep on telling this one each and every time. You should correctly understand. See, I got a small model here. One circular. Okay. This is better. Circular section. Okay, see now. I will tell about both length and cross-section. See, I written here. P is always along the length, or L is always along P. Both will do. Okay, I'll write that one. So you can tell P is always along length or L is along P. Along P. Both are same. See here now. This is a member. I apply compression. I apply compression because tension is difficult to hold here. See, this way. Or tension. My force is running like this. That the force is running along the longitudinal axis. How the force is going in that direction, that is L. Remember, I will not repeat again and again. You go through the class repeatedly. If confusion is there, some 3-4 times this one. Then it becomes more clear. See, if it is offline class, I tell at least some 10-15 times. Here only one sufficient. See, how is the force? Now, if it is a column, vertical member, see, compression this way. Now, if you apply force this way, this will become length. So, P and L both are in the same direction. So, next further. A is the cross-sectional area. The most important is when you apply the force here, it is acting on which area. See here, this way. This is the area. Here circular, it can be rectangular. See, it can be rectangular also. So A means cross-section area, means cross-section you have to cut. See, you cut here. That area what you are seeing is cross-sectional area. So the cross-section should be always perpendicular to P. I written here, I think. A is normal or perpendicular to P. Therefore, little later, whatever stress comes for, stress will come for cross-section or stresses are resisted by the cross-section. That stress will be normal stress. Why it is called normal? Symbol is sigma. That normal stress, our symbol is sigma. Sometimes people use the symbol F also. Now popular is sigma. So sigma, say write once again now. Sigma means normal stress. It is for the cross section. Now, later, one more called shear stress will come. That is called tau. That will be not perpendicular to cross section, it is along the cross section. That is called, it is called later tangential stress or shear stress. We will discuss later. So remember, at that time, I will once again explain sigma and tau. So remember, the cross-sectional area A, cross-section area A is always perpendicular to the force here. See, this area. And resistance for the axial compression or tension is developed by the cross-section. So the strength depends on cross-section. Of course, if it is compression, length also counts because some buckling part will come. That will come in the last chapter, that is columns. So till I reach the column chapter, when member is in compression, what I will do? I will see that length is lesser, so that there is no buckling chance. If at all it fails, it will fail by crushing. Okay, now, explained in the class, what all I told, write it. Once again I will tell, A is the cross-sectional area. If the force is this way, it is perpendicular to the cross-section. And see separate note later in summary. Later I am going to put a summary. There I will show a three-dimensional sketch for you. All three sides I will apply the force. Usually in the class I will give the sketch and walk out for a break. I will tell the students, for each force you decide the length and cross-sectional area A. Here if I go for break, who will decide? So here there is no break here, so I will explain there. That is a master example lastly. Okay, then P can be tensile or compressive. First consider P to be tensile. I will go a little brief. There is a limitation. Too much behavior I cannot tell here. Time also is not there. So P, see. P can be tension. Okay, now, when you apply tension here, see what happens is, I will tell behavior. The tendency of this force C is to move the point B. It is prevented here, but it is prevented from moving here only when this will give the reaction. To give the reaction or to develop the reaction, some phenomena or procedure is there. See, I will tell what will happen now, briefly. See, I will use some red color for understanding. See, when you apply the force P here, I will tell in a simple way so you understand. I can tell it in a very high level. You will go low then. See, as you apply the force P, the tendency of member is to elongate. See, I will project this point here. Initial position is here. See, I am considering elongation only on one side. If it is, suppose you apply force P on both sides without any support, both will elongate. The total of that one is the elongation. That hardly matters. Okay, now see, this is the point B. This is original A, original B. Because of the force P here, that I use a red color now for elongation, member will elongate. Actually, when it elongates, its cross-section area will slightly decrease. And when it's in a compression, when the length decreases, cross-section will slightly bulge. That all comes later when you go to lateral strain, not now. So, I'll slightly put inside. See, it will try to elongate. So, member will elongate. This elongation we call delta. My symbol is delta. See, this is lengthwise delta or axial deformation. Later you get axial deformation and also lateral deformation. At that time, I will put this as delta linear, other one delta lateral. So later, what I write delta linear is this delta. Till you discuss delta lateral, delta linear is not required, delta. Like name, time being name is delta. After reaching a stage, I will change it over to delta linear. Both are same. Okay, now, as member elongates, see, internal molecular structure is disturbed. There will be resistance developed here. So, as we apply the force P here, P is still acting, see, same P. What will happen is, internally resisting forces will develop. I will put R, resisting force R. Resisting force internally, it is spread. Now, P will be more than, in the beginning R is 0. That is very important. See, initially your P is 0. Sorry, not P is 0. P is permanently applied. R is 0. This is just reading mistake only. Initially R is 0. I'll write here somewhere. See, initially R equal to 0. Now, R will develop as the deformation starts. So, as delta starts, simple language, delta starts, R will develop. Internally. Now, still imagine R is less than P. So, P will further try to elongate. So, member will further elongate. I will not go beyond the limit now. See, initially here, I will project the point here. Now, see, now it will go furthermore. Sufficient, see, delta. Then, finally a stage will come when, I can put so many sketches here. Initially R0, finally a stage will come when the internal resisting force R will reach, or it will reach the value of P. That is, how much force, axial force you apply internally, same resistance will come. Then deformation will stop. So when your R becomes equal to P, axial deformation stops. For you sufficient. Furthermore, I don't want to discuss. It will become too lengthy theory. I told you 3-4 hours I talk for professional classes. Maybe, actually remember, recently I taken a course for basic structure knowledge. Not 3-4 hours. I think 3 classes I explained that concept there. Now, axial deformation stop. But remember, by that time, member has undergone an axial, here tension, here elongation, because it is tension, elongation of delta. Over. Now, one important term will come later. That is, now I will tell now only. What is the strain energy stored? I will tell now only. Strain energy stored. Because ideal time to explain it. Stored symbol is U. That is actually called internal strain energy stored U. This formula you know it. See, now one important aspect. As the member, as you apply a force here, member will elongate. Finally, when resisting force becomes equal to P, elongation will stop. If it is compression, contraction will stop. Both are same theory. I will briefly explain for compression. What will happen? The point will come inside here. Afterwards, after it's completely over, briefly I will explain. Now, halfway through, anywhere, if you remove the P, suddenly, see, apply tension, member will elongate. If I got rubber, you can take a rubber band. Take a rubber band, pull it here, leave it. What will happen? It will once again come back to original position. How? Because if you remove P, the R is still there. So the R is acting, see, this way, inwards. So if this R at present is balancing P. When you remove P, R will come this side. Simple example. Suppose two people are, simple example, keep on pushing each other. See, you put your hand this way, he will put hand that way. Or still example, imagine you are asked to push a vehicle. Fully you push it. As you push, suppose vehicle gets started. It's an electric vehicle. Sound is not there. Oh, sorry, electric vehicle, there is no pushing required. sorry, see, sometimes it happens. Or imagine here you are having music, you are hearing music. So you cannot hear anything. You pushing it. Vehicle starts and go. When the vehicle starts go, what will happen? You will fall forward, correct? Suddenly you will fall forward. Why? A force you are applying, which is actually earlier balanced by the reaction of the vehicle, now balanced. Or if one is pushing you this way, by hand, you push him this way. If you remove the hand, you go this way further. So the moment you remove P, this R will bring it back to original position. Now, it will come back to original position only up to a limit. Now, the property of a material by virtue of which this all, only once I am telling, you should write it, definitions all. Because why? These theory, once understood, you should write everything. The property of the material by virtue of which it will regain its original position once the external force is removed is called elasticity. This all are knowing, I think. Now, there is a limit for this one, elasticity. So this member regaining its original position is only up to a particular limit called elastic limit. Now, by chance, if you apply force furthermore, in the theory, if I give, I write this one, furthermore, beyond elastic limit, when you remove the force, it will not come back to original position, or some deformation is still left in the member. Therefore, see now, 1 minute now, because of this delta, some strain will come in the member. I will discuss it later. Stress and strain still I have not told you. Some strain will come in the member. Now, if the deformation is beyond the limit, then when you remove the force, then member will not regain original position. Some deformation is still left, or some strain is still left in the member. That is called permanent set. Permanent set means what? Permanently, see, permanent set. See, for example, simple example I will give you. You take your hand, finger use it, press by a pen, see, remove it, see, nothing happened up to some limit. But if you apply beyond the limit and leave it, see the finger here, see, you can see some deformation here, but this is elastic now, it will come back to original position. Or to make more clear, I cannot show axial, see, 1 minute. Axially I cannot show, because if I apply axial force, I will take this one. If I cannot elongate now, I will show bending. See, I will apply some effect like axial force bending. See, remove it. Once again original position. Apply little more. Remove it. Once again original position. Apply further little more. Sorry, now leave it. It got broken. See, apply little more. See now, you can see some deformation still there. Or see, if I apply further more, you can see now, see, deformation is still there. That is residual. So the deformation, or because of the strain which is still left there, that is called permanent set. Definitions you require. But in our entire strength of materials, we study when deformation vanishes, when you apply, when you remove the axial force, or you can tell our complete behavior is when it is within the elastic limit. Okay. Now, this is over now, permanent set. So, I told strain energy stored, I will clarify now only, because now is the right time. Actually, people will discuss strain energy after discussing about stress, after strain, deformation, when all the formulas are derived, then they will tell strain energy. Why I am telling? Because if I tell all those that one now, later when you come strain energy, you will forget it. This what I told now, you forget it. Once again I will start. So now remember, I will write somewhere here. Okay. Energy stored. You know, energy, see, because of this deformation, member internal molecular disturbance will be there. Some internal strain energy is stored. When you remove the force, you can tell the strain energy is released. When you release, what will happen? It will help you to regain original position. Sufficient. Now, you know that energy is always equal to work done. Work done. This is physics. And work done equal to always force into displacement. Force into displacement. This all are knowing. If you are not knowing this one, you have to believe me. That's all. Physics I can't tell here. Now, when you talk about strain energy, it is internal work done. Internal work done, or equal to internal resisting force, axial force into displacement. Displacement means deformation, displacement. Now, so your deformation will stop when R equal to P. So you know that R equal to P. Okay. Now, therefore, people usually will tell, what is the answer? Sir, it is P into delta. See, they will tell P into delta. No, it is P in delta is not here. It is not P in delta. That comes somewhere else. When it comes, I will tell you later. Now, for you, strength of materials, it is not required. Okay, now, one most important. This internal resisting force is initially zero. Initially zero. And finally equal to P. That is R equal to 0 initially, finally R equal to P. Or during this displacement, resisting force is not constant, it varies. Therefore, we have to consider, very, very important, average, this is a very, very important, average internal resisting force. That will be equal to 0 plus R divided by 2, but R equal to P, therefore equal to 0 plus P divided by 2 or equal to P by 2. Therefore, strain energy stored U equal to internal resisting force. You have to consider average equal to what? Is average internal resisting force, into displacement, delta. Displacement is delta. Okay, you write, if you want words, you write there, into that change in length. Delta means change in length. It can be increase or decrease depending on tension compression, or equal to P by 2 into delta. Therefore, remember, I will not tell once again now. This already told for you last time. Therefore, due to axial force P, strain energy stored total. This is actually total, because one more per unit volume is there, that I told you last time. So that is called U equal to half into P into delta. Remember it always. Read it 10 times. So now onwards, people forget that half into P into delta. Now, 1 minute. I cannot once again come back here. One more thing now. Sometimes they plot force this way, delta this way, they draw a graph there, and then they will tell what that area, etc. Theory part, that all there is no time. If you study any books, you will get it. My limitation here, all expressions, basic meaning, and understanding the concept and easily solving questions. So now, important is half P delta. I will do one thing now only, later I will forget actually. So, see, after some more theory, you write now. Actually, that you have to tell, or okay, no problem. I will go later, no problem. Because why? Your substitute for delta, etc. Later I will do it, nothing to worry. Because, but remember, U equal to half into P in delta. This is the original problem. So remember, this is the original. Then some will ask, sir, what is duplicate? No, not duplicate. Others are modified. See, last class I wrote P square L by 2A. And one more thing I wrote, sigma square by 2E. That all I will tell that later. So I will forget later. So I will make a small note to myself only here in the board. U to be continued for P square and sigma square. My remembering, I saw the right side corner where you can't see, I made a note there. This is one part. Now, this I can remove now, time being not required. Now, the most important part, or the very, very critical part of this chapter. See, we are applying a force P, for which internally across the cross section, perpendicular to cross section, spread across the cross section and acting perpendicular to cross section or normal to the cross section, resisting force R will come. Now, this internal resisting force R is actually called stress in the member. Sometimes people will tell you, so stress is force by area. No, basic definition is, I am not writing here, you write internal resisting force developed in the member is called stress in the member. But we never require the force. we always want force per unit area. I will tell you it later why. Therefore, internal resisting force, see, very important. What I am writing now is, I will put red color. Very, very important statement. I will not repeat. You have to go through the class repeatedly. See, the internal resisting force per, or I will put here, per unit area. I will explain later. Unit area is called intensity of stress. Intensity of stress. The most powerful term, stress. Or usually when you go further and further, you always require intensity of stress. You can see nowhere people writing that one. They simply called stress. Or simply called stress now onwards. Called stress now onwards. Symbol is sigma. Sigma means normal stress. It is normal stress. Some people use the symbol F also. No, we will use sigma only. Suppose they give me the question paper F equal to means this one only, small f. Actually, IS code for RCC and steel, or they use symbol F, FCK, FY, see, all those things. Everywhere F is being used there. Okay, leave it now. Stress sigma, normal stress. And remember, sigma stands for normal stress, means it is spread across the cross section and it is perpendicular to cross section. I will not tell again and again. Perpendicular or normal to cross section means, see, if member is circular member, for example, this way, it is this way. There is, if the cross section is here, perpendicular, or it is along that L. Now, perpendicular cross section, tension I have shown. Now, definition point of view, stress equal to force per unit area. And you know, internal resisting force R is equal to P. You know it. Therefore, your normal stress sigma equal to force per unit area P divided by A is the very powerful equation. Now, P is the force. Force actually not force. Axial force you have to tell, but time saving. When I discuss stresses and strains, so many times I will use the word force. I will tell in the beginning only. If I use the word force, it means axial force. Axial force per unit area. So P by A is normal stress sigma. Now, I will tell you why sigma is more important than P. Suppose you tell a member is loaded by 10 kilonewton, or in tons, very easy to understand practically. One member is loaded by 10 kgs. Another member is loaded by 10 tons. I will ask the question in the class. Tell me which is severe case. All will tell, sir, 10 ton. No. Force will not give you severity. Stress will give severity. I will tell it later. Later I will tell, because some practical example I will give you. Now, this is over now. Now see, we know that delta is the change in length. I am using the word change in length. In my discussion, I have taken tension, which will be increase in length, or other words, increase in length or extension or elongation if axial force P is tensile. Whereas it is decrease in length. Here also see, if the P is tensile, this normal stress is tensile stress. If P is compressive, normal stress is compressive stress. Okay, now change in length. If it is compression, it is decrease if P is compressive. Delta. Now, delta, remember, delta, if a member undergoes more and more deformation, it is bad. Suppose, for example, if you see a beam which is bent like this, you will feel afraid. See, this deformation is bad. It should be controlled. Now, deformation will not give severity. Deformation per unit length will give severity. Now you define a term called strain. Strain means it is normal strain. Normal strain. Strain symbol is epsilon. See, this way, not E. See, curvature you can see. Epsilon is ratio of of change in length to original length. Change in length to original length. Now, see, P is, you cannot tell critical or danger case based on P. Sigma will tell it. That is not, see, stress will come due to force only. Force will not give severity. Stress will tell you severity. Delta is the change in length. That will not give severity. Strain will give severity. That is why this chapter is called stresses and strain. See, nowhere you can see chapter name axial force and change in length. No, it is called stresses and strains. Means the two major part or two major terms are stresses and strains. Stress and strain. Okay, now I will tell you, therefore, space problem is there now. I write here only. You write below, don't write here. Therefore, epsilon strain means it is axial strain, or direction is axially taking place, but effect is, it's called normal strain. Why? Because for the cross section it is normal. Strain equal to ratio of change in length to original length is equal to change in length divided by original length. Or therefore epsilon equal to delta divided by L. And remember, this epsilon is a ratio, there is no unit. Whereas the stress is force per unit area, so therefore it has got a unit of force dimension wise F by L square, like Newton per mm square, or kilonewton per meter square, or even kilonewton per mm square. Anything will do, mm square, or even Newton per meter square, etc. Force per unit area. Stress has got a unit of force per unit area, or force by area. Strain is the ratio of two linear terms or two linear quantities. See, change in length is linear, length also linear, strain is unitless. Now, remember, if it is axial force is tensile, delta is increase in length, then tensile strain equal to increase in length by original length. If axial force is compressive, then your delta will become decrease in length, epsilon equal to strain equal to decrease in length by original length, or general language, it is change in length to original length. And remember, once I write this one, later if I see, I wrote just now, this all I'll remove, not required. So I wrote two important terms now. What? Stress sigma equal to P by A. Stress, and strain epsilon equal to delta divided by L. Now see, this is the basic. Now I'll put here, later, if you want by chance delta, if you want P by A, suppose you want to P for a given delta, you can write P equal to delta into A, or if you want to find the area, you can tell area equal to P by delta. High school level mathematics. High school, right here. High school level mathematics, or primary school level mathematics nowadays. Okay, and further, and also remember, epsilon equal to delta by L. So later, if you want delta based on strain, you can write delta equal to epsilon into L. Someone will ask, sir, L equal to what? Delta by epsilon. Nobody will write that way, not required. L is a known thing. Okay, so your epsilon equal delta by L, or if you know strain, if you want delta, it is epsilon into L. This I told in the last class. Okay, now further, see, using everything here. Now just 1 minute now. I will tell what happens if it is compression. Briefly, very briefly I will tell. You can write if you want note, or I will remove now. Too much I will not explain now. Very briefly I will tell if member is in compression. not tension, imagine compression. P like this. I use red color, P. This will be like this. P. Then length is L. This length is L. Same principle, because of the compression, when you apply the force, your length will decrease. So see, it will come here. This is called decrease in length delta. This delta is decrease in length. Decrease in length. So if you apply force P here, resistance will come this way, or resistance will come this way. Other all theory is same. So suppose they ask you, explain stresses and strain with, and also strain etc. with neat sketches, you can show any one of them. Both are not required. So this is for basic part. Now, there's a theorem or principle called Hooke's law. See, I am not discussing here about yield stress, then ultimate stress, breaking stress, etc. Upper yield, lower yield, theory portion, there is no time. So that all you have study yourself only. But later, briefly I will tell, 1 minute. Right now, remember. And one more thing, I told elastic limit is what? Is the limit up to which, if the external or axial force is removed, member will come back to original position. Now, Hooke's law will relate stress with strain. Stress with strain. Stress with strain, it will relate. So, Hooke's law is, see, up to statement, up to limit of proportionality. Proportionality. I will tell you why. Because elastic limit and proportionality limit are slightly different. They are very nearby, not much, but slight difference is there. Definition point. See, when you remove the external force, the limit up to which when external force is removed, it will come back to original position is called elastic limit. Now, proportionality limit means the limit up to which stress is proportional to strain. Common sense. Apply more stress, more strain will come. Now, but both are very, very nearby. So many times design point of view, practically, they take both same. They don't discuss too much. Sometimes for here for Hooke's law also, people tell up to elastic limit. But technically, not elastic limit, up to proportionality limit. I used to use red color, okay, limit. The intensity of stress, that is symbol what? Sigma is proportional to strain. See, I am telling to explain in simple language. Proportional to strain. Remember, strain is epsilon. Epsilon. Not E. One E will come. Or you can tell, see, now based on this one, 1 hour discussion is possible. No, that's all. You study books and understand. That is, your sigma is proportional to strain epsilon. Or when something is proportional, what you can write? Or I can write sigma equal to a constant into epsilon. This is called constant of proportionality. Constant of proportionality. This is mathematics. The constant of proportionality, that is, which will connect what? Stress with strain, that is a property of a material. It is called Young's modulus of elasticity. Young's modulus of elasticity. This all you are knowing, I think, when you go to college, they tell all these things. Elasticity, or technically it is called Young's elasticity, or simply we don't use the word Young in engineering field. We give, see, in physics all, the symbol used to be Y. There they give more importance to person. But in engineering language, they give more importance to property, elasticity property. So their Y in structural engineering, it is E. See, not epsilon, E, capital E. Young's modulus of elasticity, or in future we will not call every class Young's modulus of elasticity, or simply called modulus of elasticity. Simply called elasticity, or sometimes people call elastic modulus. Reverse, elastic modulus. The symbol is, remember, E. See, not epsilon. Remember, see, epsilon means strain. See, to write E, you can remember this way. Don't tell anybody. To write E, see how easy to write E. If you want to write epsilon, see, you will require effort there. See, you require effort. This will tell, oh, this is more strain. Yes, where you require effort, where you will have strain to write, that is strain. Sometimes I have seen people writing simply, see, E this way. See, I'll tell you, they write epsilon this way. They put E this way. No, see, both look same. So what you do is, now onwards, remember, strain when you want to write, strain. And Young's modulus of elasticity when you write like this. Sufficient. Furthermore, I can't tell. Now, so now I will come to further equation. I will go to some equations now. Then I will give a list of the formula for you. After everything is over, if time permits, I will do a question, or question I will do next time onwards. Non-stop questions then. See. So, your stress sigma is, I told, constant into strain epsilon. Constant is called capital E, Young's modulus, or you can tell sigma equal to E into epsilon. Epsilon. This is one equation. Or you can tell, see, later you require sigma, if you know strain, if you know Young's modulus, you can find stress. Correct. Or suppose you know stress and you know Young's modulus, you can find strain. It's a side effect. Or remember, you can also write, if you want, epsilon equal to stress divided by Young's modulus. Or suppose you want Young's modulus E, if you know stress and strain, equal to sigma by epsilon. See, stand slipped there, epsilon. Now I will tell you one thing. This is the most popular to remember. Most popular in among students. They will always tell stress equal to, sir, force by area. Strain equal to change in length by original length. Connect strain, stress and Young's modulus. Sir, stress divided by strain, sir, is Young's modulus. See, that's how people remember. So, stress divided by strain is Young's modulus. This is very popular. So, most popular version is, right here now, the most popular, or you also remember that way. Always better remember stress by strain equal to Young's modulus. Now do one thing. Once you write this one, you can ask anybody, tell me what you want now. I want Young's modulus. That only I wrote. I want stress. What is there? Therefore, stress equal to A. Go that side. No, I want, which one? Strain I want. Okay, strain, you go that side. E, you come this side. This is epsilon, this strain. Again, this is high school level mathematics. So, these all I am going to give a summary for you now, so that summary will be in the full board. I will prepare, explain everything, that summary. Okay, now. Continue little further. This all I remove now. Continue little further. See, when I rub and write here, you should write the sheet one after other one. You should not comment. He is randomly writing. I am not randomly writing. When I write here, don't see writing there. Now, start. We already know that stress equal to force divided by area. And we already know that strain equal to change in length by original length. And we already know what? Stress divided by strain is Young's modulus. These are the three derivations you have done. Start. Now I want stress formula already over. I want expression for delta. I want expression for delta, the most popular. See, your strain epsilon equal to delta divided by L. Therefore, delta equal to strain epsilon into L. So remember now, strain you can write, this is the basic formula, but that is not the popular formula. If I ask a student delta equal to PL by A, see, I'll tell later. No, you know that, see here, stress divided by strain equal to Young's modulus. Therefore, you can tell what? Strain equal to stress by Young's modulus. So, your delta will now become, replace strain by stress by Young's modulus. See, into L. This is second formula you got. Now, lastly, you also know that stress equal to force by area. Substituting, delta will come stress equal to force by area into L by E, or delta equal to, this is what people remember, PL by AE. Write 100 times. E should go that side. Go that side. Don't disturb here. E. This is the most popular formula. You ask anybody without knowing subject, he will tell delta PL by AE. Okay. Now, but people remember other way. See, systematically this way, but by hearting, see here also. See, this is the basic, but people remember what? Stress by strain equal to Young's modulus. Then they will do whatever they want. Here also, maximum people what they do is, they remember how, if you ask them, maximum people, see, they will tell stress equal to force by area. Okay, got it, clear. Strain equal to change in length by original length. Okay, that also clear. Then further, delta equal to, delta equal to, they will tell, I know it. Delta equal to PL by A. Okay, done. This is also over. Then somebody will ask you, no, I do not want P. I want delta in terms of stress. Okay, no problem. Replace P by A by sigma. Then your delta will become, see, P by A is sigma, sigma L by E. They will tell that actually this you got from this one. What to do? Sigma L by E, not epsilon. E. No area here. Okay, then further, this is the delta, you can write here, delta based on P. Remember that way. This is the expression for delta based on stress sigma. Now I want one more delta based on strain. Based on strain. They will tell, okay sir, no problem. We know that what? Sigma L by E, correct? Now see here. Sigma by E is what? See here. Again they will tell this way. Stress, if you ask them, replace sigma by E, they will tell, sir, 1 minute, sir. Stress divided by strain equal to Young's modulus. Oh, got it now. Therefore, sigma by E is strain. Oh, got it. Strain into L. This is the original formula. See, strain into L is the original formula. See, originality gone, duplicate is predominant. What to do? Life is that way, society is that way only. Originality gone, duplicate predominant. Okay, now this is based on strain. All these three you should remember. Now make a note if you want. In the beginning for simple, see one example I have done last time where I used all the formula if you remember to understand. But from now onwards, for simple cases we will use delta equal to PL by A. Whereas later when you go to composite member or temperature stresses, there you have to use delta equal to sigma L by E. There's a reason. Reason is there. And further later, when you go to lateral strain, linear strain, volumetric strain, all, at that time you have to use delta equal to strain into L. So what I told now, write 10 times and understand. Okay, now come to the last part of this discussion. See, I told there's a limit for explaining. Even now, see, I took nearly 1 minute. The duration maximum is 1 hour. I should be careful. If it goes beyond 1 hour, then a pausing will come. Okay, no pausing. Okay, little time is still there. Then I should go and change it. Okay, now see, one most important now, if you remember, in the beginning I told U equal to half into P into delta. This is the original formula. See, now do one thing. Strategy stored, I told earlier, I will once again come back to it. Now substitute delta equal to PL by AE. See, delta equal to PL by AE. Then your U will become half into P into PL by AE, or your U will become P square L by, see, 2 AE. I usually tell in the class, do not forget 2. This 2 you write here. See, those who know Kannada, I will tell them, Nannannu marayabedi. I use the same word. So many people in a hurry. See, AE comes naturally. They forget to get wrong answer. Especially for objective question. Here they will not cut much marks because this is a not objective question for you. But objective competitive examinations all, they will get wrong answer, double the answer then. So I will tell them, Nannannu marayabedi in Kannada. Hindi, mujhe bhulna nahi. Or in English, do not forget me. Which one? 2. See, for delta equal to PL by AE, no 2 here. When you go to strain energy, that 2 is the most important chance of forgetting. Okay, now, lastly, see, U equal to P square L by 2 AE. Now, continue this one, or I can continue U equal to, see, small I will write, P square into L divided by 2. There is a here, I will put A square into E. That means in the denominator, I put extra what? Extra A. I put extra A here. What do I have to do? I have to multiply by A here. See, A by A square is once again 1 by A only. Or equal to, this is 1 by 2 into P by A square into A into L by E. Those who want, they may ask the derivation also. See, or what you get now is, now you know that P by A is stress sigma, and you know that A into L is what? Again, high school mathematics. Area into length is the volume. That much common sense required is the volume, that is V. Or you can write U equal to sigma square, see, sigma square into volume divided by, don't forget T2, divided by 2E. This is not that important. Okay. This is the total. This will give you total. But sometimes people ask you, this is a total. What is the strain energy stored per unit volume? Or you can tell U equal to sigma square V by 2E divided by V per unit volume. Per unit volume. Now we will cancel, or the last one, therefore U is also equal to sigma square, sigma square by 2 times E. This will give you strain energy stored all due to axial force stored per unit volume. And lastly I told energy is force into displacement, so it will be force F into L, like kilonewton meter or Newton millimeter, etc., etc. Okay, now the time has come to give the perfect example to understand why stress is more important than force and why strain is more important than which one? Deformation. And also time has come to give a full thorough summary for all this one, so that refer that summary in future, you get complete information for further doing problems. Okay, I will prepare the board neatly. I will write and explain because time factor. I will write and explain that one. Now I am going to the final summary. See, it will start from here. See, I write a note here. You should remember something. If from here your summary starts, it will go up to there. And remember, still not over, continued. Everything I told so far, or what are all important for you, this is a summary. I will give some examples, and then after summary is over, I will start the problems. Oh, I have to tell the severity of stress and strain. Okay, first I will tell that one. Okay, see, stress is force per unit area. That per unit area is important. Strain is change in length per unit length. See, because of P, you should write yourself. See, you should write somewhere. Stress will come because of P. Then strain will come because of change in length. See, P is the force, axial force. Stress sigma is force per unit area. Delta is the change in length. Increase or decrease, I will explain. Strain is, this is not E actually, I told strain actually, I told E very clearly. See, this is E. By writing you can make out. I will make it little later sometime. This is E. See, sometime what happens is, okay, E. But you can make out there. See, and strain is the strain comes because of change in length. Force per unit area is stress. Change in length per unit length, that is strain. Now, suppose you take a member. Two members are there. So, two members. One member is loaded by, I will call in tons and kg, why easy to understand. A member is compressed by 10 kg, light. Another member is compressed by 10 tons. Suppose you ask, which is severe? You cannot tell. Depends upon what is the area provided. So you can tell severity not by P, by stress. Change in length delta will not tell severity. As the length becomes more and more, delta increases, no problem. But change in length per unit length, that's the rate of change of deformation, that is strain. These are the critical. Which one? Sigma and stress and strain are critical. Or this will decide severity. You write here, spelling I am not bothered. This will decide severity. How severe force is, you tell by stress. How severe is the deformation, tell by strain. Simple example I will give you. Imagine you have to purchase something. I will tell in Indian rupees because most of the people are from India only. Indian rupees. Someone will go and buy gold. Someone will go and buy steel. Steel for construction, gold for ornament. A person will go to a steel shop. He want to construct a building. He will buy steel for, say, huge quantity. Suppose it's some 10 lakhs. 10 lakhs money means around, for lakh is now, it's most probably 50,000 time has gone, I think now. 10 lakh means some 20 tons, around, not 20 tons, some liters are 50,000 tons has gone, sir, now. It has gone more. Okay, around 10-12 tons. Okay. 10 lakhs he paid to buy steel. Another person has gone to a jewelry shop and bought gold. This is steel he bought. He bought gold, paying some 8,000 rupees. That's all. Or little more. Okay, 10,000 rupees. Okay, I'll make same 10,000 rupees. 10,000 rupees, some item he bought. They met together. Then They asked, what you purchased? I purchased steel. How much you paid? 10 lakhs. And what you purchased? I purchased gold. How much you paid? 10,000. Oh, steel is costlier, gold is cheaper, correct? All will shout in the class, no sir. See, they know it. They tell, no sir, how it is possible? See, he maybe, see 1 minute, 10,000 he paid, he got 2.5 grams of gold, around 4,000 rupees. Okay, I think it is nearing how much? 5,000. Okay, I will do one thing. Time will come when the rate becomes 5,000. Cost is 5,000 rupees. Cost is 5,000. Or 1 minute, 2 grams. 2 grams of gold he bought. This person paid 10 lakhs and bought how much? 10 ton, no? Around say 12 tons. Or 12 tons means dividing is difficult. Say 10 lakh for, okay, 20 tons. Olden days, steel used to cost 50,000 per ton. Okay, no problem. Now, so steel person will ask, how much you paid? I paid 10,000 rupees for gold. And he will ask, how much you paid? I paid 10 lakh rupees for steel. So conclusion is what? Steel is costlier, gold is cheaper. Is it correct? No. 10 lakh rupees he paid to buy 20 tons of gold. Maybe a column, RCC column of side, some 300 mm by 400 mm. If you apply 10 ton load, it is nothing for it. Nothing. It can take up to around 30, 40, 50 tons. I know, because I know RCC also. With reinforcement, it can be made take even around up to 60 tons also. But, see, suppose you got a member here, see, a paper here, I will apply 10 kg. See, gone, see here. So, 10 kg produced severe effect than 10 tons there. Same way here, what you have to do? You should do one thing, you should find what is the force per unit area. That counts. So, he will calculate how much gold? 10,000 rupees for 2 grams. So, gold cost is how much? 5,000 rupees per gram. Per gram. Steel cost is 20 tons for how much? 10 lakhs for 20 tons. Now, if you want to compare the cost, you go to, see, if one who gave 20 tons, one who gave 10 lakhs and bought 20 tons, he should go to jewelry shop and buy 20 ton of gold. Same quantity. Then you can tell which is costly and cheaper. If you go to a jewelry shop and ask him, I want 20 ton of gold, he will faint most probably. He will look at you and second time, where you came from? 20 tons gold. Tell how much money you require? 1 gram is 5,000. 5,000 per gram into 1,000 per kg into 1,000 for tons. Oh, I have to count the number now. I will divide by 10 to the power 7. You need 500 crore rupees to buy 20, how much I told? 20 tons of gold. Now you can tell, sir, gold is costlier, sir. Or you do one thing, you give 10,000 rupees, buy 2 grams of gold. What is the cost per gram? 5,000 per gram. Go to a steel shop and ask him, I want to buy 1 gram of steel. He will look at you and tell, get out from here. 1 gram of steel. 1 kg he will give free for you most probably. He will tell, you have gone crazy. 1 gram of steel. We sell steel, at least he will tell, in kg language. Grams all you don't sell. So that is, remember, so force per unit area or cost per unit is unit weight. That's how you decide which is costlier. Or site. See, I am in Bangalore. Surrounding area, square feet weight is around nearly 20,000 rupees. If I go outside Bangalore, I can get a site for even how much? Less than 1,000 rupees per square feet. Someone will buy a site outside Bangalore paying 10 crores. Someone will buy a land somewhere here paying 5 crore. Oh, does it mean that this is cheaper? No. That 10 crore he paid for acre, 1 acre or what, some thousands or lakhs of square feet of land. Here he paid how much? maybe 2 crores for a site of 30 by 40, maybe 30 by 30 site. 30 by 30 site, there he may give free also. It is possible. So that's why I told, do not decide which is costly, which is steel by how much money you paid. Do not decide severity by how much force you applied. What is the force per unit area? That's why chapter name is stress. Come to strain. 2 persons, one rich and one poor. A poor person, he earns per day, or his monthly salary is say 20,000 rupees, little lesser. There is another person who makes per month 20 crore rupees. There are people who make per minute crores. You know, I don't want to tell the names. A rich person, he is so vast business, per month his profit is earning is 20 crore. A person whose earning is 20,000. Now, police will put a fine for an offense, or by police offense. Some government suddenly notice came to the middle what I call is a poor person, middle group. Okay, government ordered him, you have to immediately pay for your some land, some charges are there, you have to pay some 50,000 rupees. He will get a shock. 50,000 rupees. My salary is 20,000. How I can pay? No, he get worried. Suppose he has to pay, he will be in severe strain. See strain, 50,000 he has to pay immediately. Salary is 20,000. Somehow he is managing. Same if you go, that businessman who earns 20 crore per month, your government will tell him, you pay not 20,000 or 50,000 fine. They will tell, pay 5 lakh fine or 50 lakh fine or 5 lakh fine. He will tell, okay, no problem, done, I will pay. He will not feel, or 50,000 fine for him, he may not feel it. He will give 50,000 the way from your pocket you give 1 rupee to someone. The way you give, you means we average people, the way you give 1 rupee somewhere or someplace you go there, they will tell 1 rupee change is not there. You tell, okay, no problem, next time. That way he will leave 50,000 rupees. So fine will not, that charge will not decide severity. Charge per his income. Therefore, delta will not give severity. Delta by L, strain will give severity. That's why chapter is called stresses and strains. What all I told, if you want, make a note and understand correctly. Say, searching for paper. 1 minute, some time. Okay, I will remove this one now because it's gold matter I remove. So now remember, if someone tells you by force or by delta deformation, you can decide severity, you tell them no. Severity you decide by the stress and strain stored. Okay, now everything is okay, I think. Now, over. Come back. Systematically start from here. Everything I told, I will not waste too much time. So make a neat, you take a drawing sheet, big size drawing sheet, write everything from here, not only up to here, and also what I am continuing. See, second round is there. The second round of summary, continuation, both together, you write in a drawing sheet neatly using colors and sketch pen, colored pens, etc. and keep side by side. This is useful for this entire chapter. Stresses and strain, entire chapter, and also useful for columns later, torsion later, that's thin cylinder, thick cylinder, that portion, everywhere required. Deflection is not required, okay, leave it. Start. Summary. Class. Class means in the class what all I tell you have to write. That is your responsibility. Every time I will not tell. If you are serious, if you want to learn, do it. When you watch my class, it is understood. You are severe. You are serious. Severe word too much I used there. You are serious and want to pass and get good marks. Suppose somebody wants just to pass. Suppose he gets 60, 70, he will be happy. No one will tell, I wanted to only pass, but I got 60. See, he becomes happy. And one more thing, you prepare for more and get confidence Then examination, even if tough paper comes, you can pass. Okay, now P is the axial force. I already told so many times, tension or compression. L is the original length. Red color, A is the cross-sectional area. E, Young's modulus of elasticity for material. So E is a property of material. It is constant for a material. I will come to it little later when I explain furthermore. Then, first thing you get is sigma, intensity of stress. But now onwards, we will simply call stress. Stress equal to force by area. Stress will be tensile or compressive depending on P. Or, see, therefore, cross multiply stress equal to force by area. You write, suppose you know stress and area, you can find force, or stress and force and stress, you can find area. Epsilon is the strain, linear strain or axial strain. Lateral strain, volumetric strain comes later. Till you get to lateral strain and linear strain, in our class, strain means, linear strain means strain. We don't write linear strain. We use the term linear strain when one more strain comes. Till that time, suppose somebody has got an initial. You use the initial only when two people are there. If by one single name, one name, only one person is there, initial not required. Now, delta is change in length. Increase if it is or elongation or extension if force, stress and strains are tensile, and it is decrease or contraction or reduction if P, delta, sigma and epsilon are compressive. This is already told. Strain equal to change in length by original length is the basic formula, tensile or compressive. Depending upon delta increases means strain is tensile, delta is an increase in length means strain is tensile, or if it is a contraction, strain is compressive. Over. Now, basic formulas. First formula for delta. The most popular formula, delta equal to PL by, there is no 2 here, PL by A. Delta based on P. You should write here, see, class. Replace P by A by sigma. Then your delta becomes sigma L by E. No area here. Or stress by Young's modulus is strain. See little later. Here. Therefore, it will become strain into length. That is a basic formula. Okay. Now, most powerful. Remember always the easiest way to remember. Stress by strain is always Young's modulus. Therefore, if you know stress and strain, by this you can find Young's modulus. Or, if you know strain and Young's modulus, you can find stress interchange. Or, if you know stress and if you know Young's modulus, you can find strain here. Class means I am telling something that all you have to write. U is strain energy stored. U original or basic formula, see, original or basic formula is always half into P into delta. Now, write a note, class. This delta you replace by PL by A. Then it becomes half into PL by A, P square L by 2A. This 2 dangerous 2. Do not forget me. In Kannada language, nannannu marayabedi. Right. Or, if you know the stress and volume, you can find U by sigma square V by 2E. I told adjustment there. These are all you total. Also remember, you divide this by V. This is the most important. Sigma square by 2E will give strain energy stored per unit volume. Okay. Now, very, very important. PLA. See, in the class, write here, I told write here. It looks like writ. Okay. Write everything told by now. See, start writing. P is always along the length. Length is always along the P. Both are same. Along the length is P. Or how is your P going? Same way length will go. You should write. Now, take cross section. This is cross sectional area. It is perpendicular to P. So that all already told earlier by me. So many times I told, see I written here also, everything where I told, cross-section area I told. So you should write extra here. A is the cross-section area, write extra here. What? It is always what? Normal to P. Normal or perpendicular to P. Perpendicular to P. And L is always along P. Remember. Now, simple example, right? A one-dimensional member, simple case. If a member is this way, I have taken a rectangular section, it can be circular also. If the force is, see, if the force is this way is the force, that is length. And, see, cut. This is area, see, this is area. Whereas, if it is a vertical member, column, see, if you apply force this way, along the force is length and perpendicular force is cut. This is the area. Still not over, continued. I will rub everything and continue once again from here. Everything right in a drawing sheet. Furthermore, even that gold and steel I told, that fine of 50,000 rupees once for what? Middle class per person earns around 20,000 per month. How strain he will feel. And 50,000 rupees fine for a rich person earning in crores is nothing. That all you can write. See, such things if you write, somebody may laugh. Hey, what is this? You wrote money matter. You tell him, keep quiet. He told, I understood. What he tells is useful for me. I write. Do not interfere. If you have enough courage, come, let's go. Talk with him. Let's see what all you tell in front of him. I tell crude method so many times, easy method. Does not mean that when I solve a problem, if I am solving, I never use a single crude method. I don't require. But I use pure technical only. But students will not understand. So crude is required. Again I told, exam-oriented class. Some will tell, sir, this is much better, sir. Sometime I will tell, there's a systematic way of solving this problem or understanding the principle, or a crude method also is there, very effective. What do you want? Sir, please tell crude, sir. Systematic, sir, later I am going. The remaining, some will tell systematic. They will tell him, hey, you stay back. We will go. They want to pass. They are not bothered too much about that high level of knowledge. So even you also, if you have high, if you gain high, actually all this principle, your knowledge will improve, no doubt. But limited I am telling. Okay, I will start second round now. Now, summary continued. Yeah, I told, summary continued. It started last time. Actually, still continued, but just one small part. One table I have tried. All these, everything. See, just now what I finished. This full and one table coming up now. Table means just a unit problem. All those should be in one drawing sheet for your reference. Okay, start, continue. I just now considered one example for one dimension. See, this way member, this way member. Now, consider the case of a 3D example. See, this way. All three sides are along, in all three directions, forces are there. Later what we will do is, we will call one of them X, other Y, other Z. That all later, when the time comes. Class. Later, when you go to volumetric strain for a three-dimensional block, when they give these forces, 10 marks question can come. Then this will completely make it clear. If you write this correctly, problem over. Then simply formula. So at that time, this is very, very important. So, and class and also warning. I give plenty of warning in my class. Write warning. Later, when this case comes, I will not explain. Just for a courtesy sake or to remind you, I may tell, go back to class number 2 table. Thoroughly explained. Okay, your responsibility. Start. Now, see, this way, see, here one more thing you are right. Tension compression is not required for us. That is just, that you require there. There you require tension compression. Why? Tension will create increase and compression will create decrease. There you worry. Here not required. Here we want for each force what is length L and area A. I already told you, if the force is this way, that is length, along that is length, and for a force this way, cut on what area it is acting, that is area. Or see, I'll show it here. If the force is like this, see, this is length, this is area. If the force is like this, along the force, this is length, this is area, see. Okay. Which is forgotten now. Okay, last one, this way. And if the force is like this is length, this is area. Furthermore, I can't tell. So, see, correct, in the class usually I write this and go. I will ask them, you fill up, then I will write, you check correct or not. Here that provision is not there. So, that will be there when if I take live classes. In the comment section write whether you prefer, whether live class is still better for you or not. You see the enjoyment if you come live. Of course, if you come live, I will see that maximum mistakes are made by you. Purpose, not enjoyment, correcting it. What mistake you will make, I will see that you will make the mistake so that later when you go to exam, that mistake you will not make. You will not make. Purpose, always remember, you will learn by mistake. Sometimes I will tell such a convincing way something wrong. Some wrong thing I will tell. Such a convincing way that people will believe me. Then I will tell that is wrong, be careful. That is a mistake you made, now correct it. So many concepts, my students remember it that way. They will tell, sorry, lifetime I will not forget. Some of the concept where they make mistake, all I have to do is look at them, they will tell, sorry sir, got it. Why? So much, they made multiple number of times mistakes. I corrected it. So, prefer come to life. One more thing, I forgot to tell. In the comment section, you should express your views. I am not asking you to praise me. No, I am not asking you to praise me and tell you are so not required. You just express your comments, whether you are following or not, or whether the class is required to be continued or not. See, you should write. Yes, when more and more people ask for it, I get inspiration. When more and more people reply, yes, everything is clear for me, crystal clear, no doubt, I am really learning, that gives inspiration. You don't have to praise me. No, I am not asking you to praise me. Sometimes people will do that one. That is their choice. I will not feel elated when someone praises or when someone scolds me or tell nothing clear. It never happened so far. I will not feel bad. I will only know, I will be knowing that he does not deserve to get education. I will tell that way only. If my class is not clear, I will tell that way. I got that confidence. So, therefore, use comment session. You fill up with the comments, plenty of comments. Let it start pouring in. So, that means I get more and more inspiration. Just your idea, how any difficulty you are feeling or any point you want to be explained once again, tell me, no problem. See, when you tell response is more important. In the class, how response comes, I know it. I will look here, clear, sir. They will tell that way. Not a single one will tell, sir, no, that will never happen in the class. Start. See, now I explained thoroughly. For 200 kilonewton force, length is 150. I will not explain again and again. See, along the force. Where is the red color? Here. I want to write red color only. Length is 150 millimeter. And area is, see, this way. This is 100 with 100. 100 by 160. 100 by 160, it is in mm square. Unit I will tell. See, your next box coming up, last box is units only. So many people make mistake in units. In my class, I eliminate it. I know how to teach so that unit mistake is not made. Now, For 175 force, see, length is 160 millimeter, and for this force, this is the area 150 by 100. Anyone you can write first, no problem. Answer is not required. That much millimeter square. Lastly, some will tell, oh, 150 used, 100 used, 160 used. Now 100 length is pending and this area is pending. Don't do that way. You think once again, for this force, see, for this force, length is 100 millimeter. And for this force, this is the area, what you are seeing area, 150 by 160. 150, okay, actually mm is not required here, understood, because mm square is there. 150 by, correct answer, first is by chance any mistake, for first one, 100 by 160, second one, 150 by 100, correct, this one is 150 by 160, 160 mm square, that's all. Warning, will not be explained once again. But now, one very, very important class right here. See, you should write, we usually solve the problems in newtons or kilonewton, linear, millimeter or meter. So stresses usually we consider in Newton per mm square, rarely Kn per mm square. But to get in Kn per mm square, you can first should get in Newton per mm square. Now, at present, in so many codes also, they stopped giving in Newton per mm square. They give in Pascal, kilopascal, megapascal or gigapascal. See, Pascal is a very small thing. So, forgot to write one small thing there, I will add lastly. So, usually most popular is either megapascal or gigapascal. These are the most popular. Now, do one thing. First, you see definition. Actually, I do not agree. Pascal is usually, they give this one for stresses and Young's modulus. Actually, Young's modulus also is a stress only. Why, I will tell you little later. You know, this Pascal is a pressure unit. Pressure and stress are different. So, personally, I don't agree. If the committee comes in front of me, I will tell them it is wrong to mention in Pascal. Pressure is external, stress is internal. By telling Pascal, the feeling will not come. The feeling will not come. Like for Indians, you tell in some German unit or Russian unit or a pound dollar, people understand. Say some Japanese unit money, you don't understand. You tell in rupees. Or dollar is okay. Somehow people are knowing. But poor, uneducated people, they understand only rupees. So I will firmly tell them, you should stick to Newton per mm square. See, then the feeling will come. 1 Newton force for an area of 1 mm square. See how crystal clear. I don't know why they made it. Universe internationally accepted. So I have to accept. That way in the IS code, so many irregularities are there. I pointed out one by one. If opportunity is there, I will make an issue of it. Simple, politely. Okay, start. Note, 1 Pascal is a pressure of 1 Newton per mm square. I told class means I told pressure I don't like actually, but anything, see, force per unit area. 1 Pascal is a pressure of 1 Newton per meter square. That is, if you have area of 1 meter square area, a force of 1 Newton is actually almost 100 grams. Very, very small. So, but that is the basic. So, note, we usually want in Newton per mm square. Very important. See, we usually want everywhere to come to Newton per mm square. Now, you write, what we will do is, if they give kilopascal or megapascal or gigapascal, how to bring it to Newton per mm square. That is what you want. Start one by one. If megapascal given, you should know mega means 10 to the power 6. So If megapascal given, it means 10 to the power 6 Pascal. Continue. Actually, later, see, this summary is important. You don't have to worry about these things. This is, I am proving it. I don't want to give simply answer. 10 to the power 6 Pascal. That is 10 to the power 6 what? Newton per meter square. Now, meter we do not want. Newton we want Newton only. We do not want meter. We want right here. We want this meter to replace by millimeter square. So 10 to the power 6 Newton. Newton, you keep quiet. Meter to millimeter I want. See, when per is there, divide. Meter to millimeter, 10 to the power 3. You should know that one. 10 to the power 3. But meter square is there, that square. 10 to the power 3 square is 10 to the power 6. Sometime in the colleges or when I take first time class, I will tell 10 to the power 9. Student will make a issue. Sir, no sir. 10 to the power 3 square is not 10 to the power 9, sir. It is 10 to the power 6, sir. Why? I thought it is 10 to the power 9. 3 square is 9, no. They are not knowing me. No, sir. See the voice. Sir, you can't do that way, sir. When you take power this way, it will multiply, sir, not take power. I will tell, oh, sorry, confusion. Okay, excuse me. I am very sorry. If I make such mistakes in future, hope you will correct me. They will tell, yes, sir, we will do it. After 1 or 2 classes, then I will ask something. Are you going to correct me? They will tell, no, sir. On that day, we thought you made a mistake, but then we realized you are fooling us. Then I will tell them, I am not that much weak in mathematics. Actually, first of all, I am not weak in mathematics. Such a simple thing, if I am not knowing, I am not fit for teaching. Then they will agree. Then if I tell wrong also, their voice will come down. Sir, they will tell. They will never tell in that voice, no sir, that will not come. So, that's for fun I told. So, it is 1 Newton per mm square. Therefore, remember, 1 MPa given, it is nothing but Newton per mm square only. Okay, lastly, if gigapascal given, giga means 10 to the power 9. It is the 9th floor. Okay, now, 1 gigapascal equal to 10 to the power 9 Pascal or equal to 10 to the power 9 into, oh, see, actually Pascal I want to come, I made a mistake, I first thought I will convert later, I will change it. See, now 10 to the power 9 Pascals. Now Pascal to megapascal, see, you have to come reverse now. Why reverse? See, if you want a giga to Pascal, giga is higher, 10 to the power 9. When you want to bring Pascal to mega, you have to come up 10 to the power minus 6 megapascal or 10 to the power 3 megapascal or 1 gigapascal equal to 10 to the power 3 megapascal. Megapascal we are knowing, oh, that is nothing but Newton per mm square only. So finally, if gigapascal given, it is 10 to the power 3 MPa or Newton per mm square. Consider, see, these are very, very popular. Which one? MPa, GPa are very popular. But rarely, you do not know exam, they can give kilopascal. I don't think anybody anywhere given so far. I don't think anywhere given. So what to do? In case kilopascal given, then it bring to megapascal. Kilo first remove, 10 to the power 3 Pascal. 10 to the power 3, kilo to mega, you have to come up by only 3. But reverse you have to come. Mega is bigger. 10 to the power minus 3 Pascal. Sorry, megapascal. Or 10 to the power 3, 10 to the power minus 6 is 10 to the power minus 3 megapascal or 1 kilopascal equal to 10 to the power minus 3 megapascal or Newton per mm square. Square is there. Now, final summary you write. These are not required. Note, this you write 10 times. Write 10 times. We imagine the case when we want in Newton per mm square. That is the most popular. Okay, start. Then, if megapascal given, we know megapascal is nothing but Newton per mm square. That itself is Newton per mm square. Therefore, KQ. In my class, KQ means keep quiet. I will tell the students, if they give MPa, it is nothing but Newton per mm square. Keep quiet. Whatever they give in MPa, that itself you take as Newton per mm square and continue over. Keep quiet. If gigapascal given, see, mega is 6th floor. Giga means 3 floors further upper side, floor language. Come down by lesser level. How much? 3 floors. So multiply by 10 to the power 3. Giga becomes mega. Multiply, if they give in gigapascal, multiply by 10 to the power 3. Then it will become megapascal. Once you get megapascal, once again keep quiet. It becomes Newton per mm square. And if kilopascal given, it is lesser than mega. Multiply by 10 to the power minus 3. We get MPa, that is Newton per mm square. I forgot one thing now, you can add. By chance, if Pascal given, I forgot to write that, nobody will give, then multiply by, usually so far never seen, multiply by 10 to the power minus 6. Why? Ground floor to 6th floor you have to come up, minus 6. We get in megapascal, that is nothing but Newton per mm square. Keep quiet. Therefore, lastly I will tell, when you want in Newton per mm square, if MPa given, keep quiet. That itself is Newton per mm square. If giga given, 6th floor is mega, remember. Giga given, oh, bigger. Then multiply by 10 to the power 3. 3 floors you have to come. Multiply by 10 to the power 3, giga becomes mega, over. That is Newton per mm square. If kilopascal given, it is below by 3. Multiply by 10 to the power minus 3, or divide, no, stick to one concept, minus 3. Kilo becomes mega. Okay, then, or if simply Pascal given, so far I have never seen anywhere, then multiply by 10 to the power minus 6. Everywhere bring it to MPa. The moment you bring it to MPa, it is Newton per mm square. Over. Now, the last part of the summary, that is your most troublemaker for you, unit problem. I will write the full board and explain. I will write and thoroughly explain for you. That's the last part. See, once I explain today, this is the last summary continued, but remember, last part. With this in your drawing sheet, we'll close here. Once I explain today, in future, in the offline class, in front of me, students are there, I will tell them, you make once again mistake, remember, after so much I will take at least half an hour for them for this one. I will ask them, they will tell, I will try to trap them also, but here no trapping. That we will see when you come live. Therefore, some will get afraid now. Oh, better not go for live, I think. Live means he will ask doubt with us, make us make mistake. Recorded means everything is correct. Don't feel that way. Okay, now, what we are considering. We don't know what you are considering. Okay, here, these are all what we are considering. Anything forgotten? I think no. Everything is there. If I forgot something, I will add here. I will add here. Hope it will be visible. I will just check it. Because after writing everything, yes, space is there. Okay, start one by one. See, axial force P. It should come, one thing forgotten now, you should write. If it is a force means dimension is called F. It is F, F means dimension. F is not the force, force is, F is dimension for the force. And if it is linear dimension, linear or length, etc., dimension is L. That's all you require. See, F, L, time you don't require here. The time will not come here. It comes only in dynamics part or kinematics. Here it will not come. Or for impact load it will come, not in syllabus. So, we will go round and round in force and distances. When force comes, it is F. Dimension, not unit. Linear is L. Unit means, see, 1 centimeter also is L. L means not length L, linear. Remember, L means linear. Linear dimension. L means linear dimension. F means force. It is force. See, 1 millimeter also is L. L means linear dimension. Centimeter also linear. Kilometer also linear. So, but I will write which are required for you. Anyway, once you understand, you can do it. See, force P, dimension is F. Means what? It is F. Unit, Newton or kilonewton. Some rare case they can give meganewton or giganewton. This is very rare. Remember, this is not your GPA, MPA. This is force unit. That is Pascal. Here there is no Pascal. If they give meganewton, 10 to the power 6 Newton. If they give kilonewton already there. If the kilonewton means 10 to the power 3. This is not that Pascal. Don't confuse. That I given a box here that is for MPA, GPA, Pascal units. This is force. Okay, now length L, dimension is L. Now unit, millimeter or centimeter. Usually we do not consider centimeter at present, but still write here, or meter, etc. Even kilometer also will do, but no, somebody will laugh at you if you solve a problem in kilometer, in strength of materials. Okay. Then area. It is, area means what? It is linear square, centimeter square like that. So L square, L into L means millimeter square or centimeter square. Usually you don't consider, or meter square. Don't write kilometer square. We are not going to buy the land here. Okay, over. Stress sigma is force per unit area. So it is F by L square. Therefore, what force by linear square? See, plenty are there. Newton per mm square, comma, Newton per meter square, anything will do. But this is a popular, most popular. Other popular is kilonewton per meter square, millimeter square. This is also popular. Or kilonewton per meter square, etc. Apart from that one, also Pascal, kilopascal, megapascal or gigapascal also there. But if they give Pascal, we will bring it back here. Over. Then strain. You should know how many times I told strain is the ratio of change in length to original length. So it is change in length is linear. Oh, one important. What happened here? Oh, sorry. See, some little space problem here. Not a mistake. I have two things there. Okay. See, I didn't see it. Okay. Two terms are there. Okay, we'll manage. I'll shift it. What is there? Space is there. See, I was wondering where delta has gone. Okay, now correct. These are all called print mistake in my class. Okay, now stress over F by L square over. Change in length delta. How much length changes? Means it is linear quantity like millimeter or same as L or centimeter, not used, meter. Don't tell in kilometer. Over. Strain, you should make a note. Strain is ratio of change in length to original length. This is linear. This is also linear. It's a ratio. It is linear by linear. That linear by linear. Therefore, remember, no unit. No unit, or you should write unitless. No unit, unitless. Modulus of elasticity. See, once again I will tell you, just to understand. I told stress is proportional to strain. You go there, go that side. And stress equal to Young's modulus into strain. Strain is unitless. Therefore, Young's modulus will have same dimension and unit as stress right here. So in future, when you write Young's modulus, remember it has got a stress unit. You should tell stress unit. So it is E is, I write here, first of all, same as stress. Therefore, F by L square. Unit also same as stress. Therefore, same thing here. See, Newton per mm square or Newton per meter square, not used actually. Kilonewton per mm square, this also half of popular, or kilonewton per meter square, etc. Over. Strain energy. See, I'll write here. Strain energy U total is, it is work done. Formula is half into P into delta. Force into distance. Be careful, not force per distance. So P is the force, delta is linear. So it will be FL, not F by L, F into L, or like Newton millimeter or Newton centimeter, Newton meter. I keep on writing kilonewton millimeter, centimeter I am not writing, kilonewton meter, etc. etc. Now that is total strain energy. Now lastly, strain energy stored per unit volume. Strain energy is what? In what? New force into distance, but per unit volume. So divide by volume. So it is FL per L cube. Why L cube? Volume is there. So it is Newton millimeter per millimeter cube. Some will tell Newton per mm square. Wrong concept. That is a wrong concept. You should not tell Newton per mm square. Not wrong. Concept is wrong. It is not clear. Newton millimeter per millimeter cube, or it can be, I'll stop now, kilonewton meter per meter cube, that way, etc. etc. Sufficient. I think everything is over here. Nothing left out. This space is not required. 1 minute. Sigma force by area over strain epsilon by, I think yes, everything is over. I don't think anything is required now. In case required, I will give a warning to you and tell add to the table. You should do that one. See, I will tell immediately, not late. Maybe next class I will tell. Next class I will tell. By I think nothing is there now. In case I remember something, I will tell you, oh, this is forgotten there. Add it. You drawing sheet, you add there. Okay. Now everything is over. Now class has become too lengthy. It is already more than 2 hours. So I should conclude the class. Remember, still I am not fully decided about continuation. I will tell it. Actually, I don't want to talk. Many people subscribed. Okay, good. They came to my channel, subscribed. Views are reasonably okay. But no, view duration is very small. I am seeing average of around 2 minutes or 2 to 2.5 minutes per that full class of around 2 hours. When I upload a class of 2 hours, if average you see 2 minutes means it is crystal clear. You are downloading. Yes, it is your right, but I should see people watch. No, it is not any purpose for me. I should get satisfaction and I should gain not confidence. I should have enthusiasm to do it, or I should feel yes, people are correctly going to my classes like that. No, this is very bad. People want to save the data for unwanted things. I know they don't want to waste here. They will download and see. See, it hardly matters for me. In YouTube, all when the watch hour increases, some extra benefits are there. I am not telling for that one. Now, subscription based 1000 is a limit there, as it reached already. I saw today suddenly there's a heavy jump. More than 120 subscribers came in one day. That is, people liked my class. But this is very bad. Like yesterday's story I told, majority are putting only water there. Thinking that what? Others are putting milk. No. Really bad. Some will tell, why you want that watch time? See, when you do something, when you realize that people are watching, then only you get satisfaction or you get spirit or enthusiasm to take more. You don't know how busy I am now. Do you know what is the time now? It is night 3 o'clock. Night 3 o'clock now. That's why I am talking little slowly, not to disturb others. This much time I am struggling among my busy schedule. Still you want to do that one means I will see this class, I will see, then worst come worst, I will tell goodbye. That's all. Comment section you should write all these things. That is, if you want to use your data for that purpose, I should know that people are seeing it. This is service-oriented class I am making. It is not a paid course. In the busy schedule, I am doing this much. Okay, I can't tell further. I told already. All I have to do is just stop if I don't feel comfortable or not satisfactory. I will think this generation of students doesn't deserve my class. Okay, you go for a better class. Let me see which is the better class. Okay, now I can conclude, but I decided a class is incomplete without a problem. So I will do one thing now. I will remove and one very important problem I will solve now. People, so many are there, they will tell, one problem. Why? It is like food, I told. Problem is like food. These are all like, but actually remember, when all these are clear, then only problem becomes clear. So, short question, I will write on the board, solve, and then explain to you. Then onwards, remember, next class onwards, marathon problems, only problems. I hope to come live earliest possible if the class is continued. Okay, I'll write the problem and record it. Okay, now we'll conclude the class with a numerical question I wrote. Before that, remember, first, previous class, I told so many principles, explanations, theory, even today some derivations are done. First you write all of them systematically. So till that summary, final summary, that table, everything right. Then start problem. When you start problem, last time one problem solved, I written here, see, somewhere. So last time one problem solved, you take that as question number 1. Now you should write. One homework given there, solve as question number 2. You solve and make entry. I think you got the answer. Question 3 is here. A steel cable is of length 4.75 meters. That's a steel cable. It is required to support a load of 57.25 kilonewton. This 57.25, I set the question so that I get round number. Because rounding off, I should tell you next time. So today I do not want to discuss about rounding off, decimal round off. So I set the question so that round number will come. You don't bother. The allowed stress is 225 MPa. See, next time I will talk about this word allowed stress, yield stress, ultimate stress, factor of safety. I will talk next time. Today you believe me. I think by this time you got confidence that I can be believed. Okay. Find the required allowed stress is 225 MPa. They want to find what is the required diameter for the cable. Also find change in length for the cable. Take E equal to 200 GPa. This also I will give you next time. Different materials, how much E you have to take if not given. Now, first put a sketch. Show a cable. See, 1 minute now. See, very important note you have to write. They told required support a load of 57.25 kilonewton. So when you apply a load on a member, it will either compress or in tension. When data is not given, it is your choice. You can take whatever you want. But remember, if they give a rigid member, you can take either tension or compression. No problem. But somewhere in the question maybe hint may be there. Find decrease in length. Oh, that means compression. If no hint is given, your choice. But remember, when they give a cable, see a cable here. If a cable given, I have to lift the fan here. See, a cable can only lift the load. See, you cannot take a cable, apply a load this way. See, a cable is a flexible member. So flex cable, wire or rope, if they tell load should be tension, means what? You can suspend. You can put a cable like this and hang something. You can't put a cable this way and apply a load. So be careful, make a note. So even if they are not told, it is going to be suspended load, so member will be in tension. Where I written? Somewhere I wrote it. See, axial force tension in the class. That you have to write. Common sense it is. Otherwise they will tell, if you take compression, what nonsense is that? Cable given, he is taking compression. What is that one? Okay, start. First, put the sketch here. See, reaction will be there. Wherever you take cross section here, you can see a circle of diameter d. Before that you have to write, see, let d be required diameter for the cable in millimeter. See, what they want? What is the required diameter? Today briefly will solve. Start. If you cut the cable, you can see a circular section of diameter d, cross section area equal to pi by 4 d square. This will come in mm square. Why? Because you took in d in millimeter, this will come in mm square. Okay. Now, write all the data. One, see, not this way, exam not required. You should write something here. See, note, class. You write here. When you substitute and solve stresses and strain chapter, you usually consider newtons and millimeters. So you write here, everything's all substitution we will make in Newton and millimeter. So anything else given, you have to convert to Newton and millimeter. Remember, start. Axial force P, 57.25 kilonewton means 10 to the power 3 Newton, tensile. Initial length, 4.75 meter, convert to millimeter. Elastic modulus given, 200 GPa, where is it? Now you know it, equal to 10 to the power 3 MPa. MPa means Newton per mm square. This is data. Then they told allowed stress is 225. What is allowed stress? What is permissible stress or safe stress? Ultimate yield, all I will tell in next class. If the class continues. Okay. We have, see, now stress given. They want diameter. Diameter means area. You should write there. Stress is given, force is given, axial force given, and some cross section required, cross property. So connect the stress with the force. We have stress sigma equal to P by A. Substitute sigma equal to whatever sigma is allowed, 225. Substitute 225 equal to P by A. Substitute here, you get the value of D, 17.999, see, millimeter. Therefore, you can take almost 18 millimeter. Next time I will do a question when 17.34 all comes. I will tell you how to round off. Today, round number came almost 18 millimeter. So, answer is for the cable, you should write here. Therefore, for the given cable, if the allowed stress is 225 MPa, then to support a load of 57.25 kilonewton, the cable should have a diameter of at least 18 millimeter. Further discussion next time will come when I do for double limitation. Today simple question, but important question. Over. Now, anything else required? Then they told something. Also find change in length. See, usually they will give you elongation. If they give elongation, people know their tension. They are trapping you. Also find change in length for cable. Take E value. Actually, E value require later. Start. Lastly, to get change in length for cable, that is delta, understood. When you find change in length, you need cross-sectional area. What area you got, diameter you got, you have to use that answer. Okay, start. That also I will tell you next time. Sometime that result you have to use, sometime you should not use. Next time I will tell. Today simple. So for D, delta equal to PL by A, crystal clear. PL area, pi by 4 18 square into 210 to the power 3, you get 5.343 millimeter increase in length or elongation. Over question. Now one note, it is possible in the question that length may not be given because their main purpose is to find diameter. To find diameter, length is not required. It comes for delta. So they may not, you write a note here, they may not give the length. They may not give the length, but they may ask you change in length. No problem. You write, let L be the length in meter. See, you substitute delta equal to PL by AE. Or you can write one statement here. See, you write here, let one statement, space is not there, you write there. You write, I am dictating now. Let L be length in millimeter. Okay. Then substitute delta PL by AE. P into L is L only by AE. Your answer will come in terms of L. But very important that L should be in millimeter. Now, suppose now they tell, no, I decided length to be 4750 millimeter. Substitute L equal to 4750. You'll get back this answer only. Okay. Simple question. Already too late now, late night. So, therefore, I am going to conclude the class now. It's lengthy. Every class I will make lengthy only. Why? I cannot give half an hour class, 1 hour. It's an exam-oriented course. Minimum time required is at least 1.5 hours. I will try to upload more and more classes. That is almost per day one class. If the course is continued, I will almost upload almost everyday classes so that much before exam, or at least when exam comes, what all I told, that much completed. See, I won't take responsibility. I will try my level best to complete maximum possible. Okay. Thank you for going to the class. Again, as usual, I usually conclude, study thoroughly, gain more knowledge, and have good success in examination.